So here's an example now of a ductility determination applied to double reinforced section. So given a section as shown with Fc prime and Fy also given the material properties, all the necessary dimensional properties of the section is also given, including the air of steel and air of steel in the tension side. Okay, so this is at the tension side and this is at the compression side. Also, we are asked to determine the moment capacity using a phi value of 0.90. Okay, so how do we check the ductility? Okay, so the procedure is still the same with that of the single reinforced section, but only the formula is a little bit different. So we check ductility by solving the maximum steel reinforcement ratio for double reinforced beam given by this formula. So check what is your beta 1. Beta 1, since this is less than 28 megapascal, so your beta 1 is automatically 0.85. So you solve for parameter m, Fy over 0.85 Fc prime, so this is 300 over 0.8520, this is 17.65. And rho prime is simply solved. This is now the actual. Okay, so this is the actual steel reinforcement, AS prime. Okay, but when there's a prime there, you also must have a prime there. Okay, so you use 500 divided by 250 times 400 equals 005, and then your Fs prime can also be computed on the basis of 600 C minus D double prime over C. Okay, so the problem is we don't have any value of C yet. Okay, so we have to locate the neutral axis using equilibrium condition. Okay, so how do you locate the neutral axis? So you just use the couple C is equal to T, where C is equal to C1 plus C2. So we add a C1, and then this is a small letter C. Okay, C1 plus so sorry 0.85 Fc prime beta 1 CB plus AS prime. This is now your AS prime Fs prime. Okay, is equal to AS Fy. So the assumption here is that you have to begin with an assumption is that your Fs prime is less than Fy, and your Fs is greater than Fy, which means that steel here in compression does not yield. Okay, while steel here in tension yields. Okay, so this is now yield and this is not yield. Okay, so this is this value here is the one that is referred to as your A. We know that A is equal to beta 1 C. Okay, and then substituting the value, so this is 0.8520, 0.85 is beta 1, C is unknown, 250 is the B. Okay, so the width is 250 B. This is beta 1, this is Fc prime. Okay, and then this is plus 2500 is the, I think there's an error here. The area of S prime is 500. Okay, so there is an error here. It's not 2500. Okay, so this is 500, and this is 600 C minus 50 over C is equal to 1000 times 300. Okay, a calculator can easily solve this problem. You can use your scientific calculator to check directly this problem, or if the calculator cannot do it, you have to solve for a quadratic, I think it's a quadratic equation in C. Okay, so let's assume that this is now the the value for C using a calculator. We check it. What are we going to check? We check the assumption. Okay. So upon checking, what are the assumptions? Steel not yield in compression, steel yields in tension. Okay, so let's check it. So Fs prime is 664.44 minus 50 all over 64.44 is less than Fy. Therefore, assumption is correct. Okay, it does not yield. How about your Fs? Okay, Fs is 600 D minus C over C. This is 3124 greater than Fy, so it yields. So the assumption is again correct. So when all the assumptions are now correct, you can proceed with the determination of your raw max by using the formula 0.75 of raw SR, raw balance SR, okay? So raw balance SR, 0.85 over M, beta 1 over M, okay? So remember the formula, beta 1 over M, 600 over 600 plus Fy, okay? So this is the one. Beta 1 M 600 plus Fy plus it's the raw prime Fs prime all over Fy. Okay, so this is now 134.35 as computed. This is 0.026 and the actual AS over BD is 1000 over, this is the intention, 1000 over 250 and 400, you get a 0.01. And then raw minimum BR is 1.4 over 300.047 and compare it to 0.0037. You choose whichever is greater. Okay, so your minimum raw now double reinforced is 0.0047. Then we just compare it on our conditional equality. So this is raw minimum double reinforced is less than raw actual less than raw max. So is this true? Okay, so since this is true, then your ductility is satisfied. Okay, for the moment capacity, so you simply directly substitute your C. This is actually, I think, C1. Okay, your C1 D minus A over 2, which is 0.85 FC prime AB D minus A over 2. Simply substitute each. Okay, don't forget to double check it at home, no? So kung tama yung computation natin. And then you simply multiply this by 10 to the negative 6 to get a kilonewton meter here, okay? And then for your Mn2, you substitute AS prime, Fs prime, D minus D prime, or double prime, I mean, it's 50. So again, you multiply this by 10 to the negative 6 to obtain a kilonewton meter, and then add the two multiplied by 0.90, you get your final, you call this now your resistance or capacity, moment resistance or moment capacity in terms of PMN. Okay, so that's the way how to solve the problem for double reinforced section. Okay, thank you.